Good afternoon, Anna. Everyone. Good afternoon. Are you able to hear my voice today? Is it audible or feeble? Yes, yes. Okay. Right. Yeah, good. Okay, right now. Then come to here. In the previous class, I think you faced some audibility problem. Some audibility problem, and you faced a problem a little bit tough to hear my voice even in the recorded video. But that time I could not do anything there. Okay, but today I think to some extent I tried my level best to adjust the volume. Yeah, and in the recorded video, I think all of you followed one important concept: how to substitute the limits. All of you understood now that substituting of the limits, upper limit, lower limit in integration, or do you have any doubt? Yeah, yeah. First we have to substitute upper limit and then lower limit. Okay, good, good. Yes, yes, yes. Um, okay, better we go with some example so that you will get more clarity. Right here on the concepts what we discussed previously. Right. Previously, if we take one or two examples, two more examples. Why? Because that is actually little bit, not much, complicated. So if you understand properly, it won't make any trouble. Okay? Otherwise, it troubles all the times. So better we go deep into that concept. Right? Here, suppose one more example in the same way what we did in the previous classes. If I ask, find find the velocity of a particle. I don't think so. My voice is low now. Huh? Now only all of you told it is audible. Yeah, yeah. No, I think Mr. Nandu, it's audible only. Yeah, it's high only. Yeah, they are saying all they are saying. I think it is a problem with you at your system. Okay. Find the velocity of a particle. Here, particle moving with an acceleration. Say some a is equals to, he said, like uh, 2x plus 3x squared, even like this, right? Uh, Consider it is started from rest. Okay. Before starting the problem, Anna, better we try to recollect what the formula to be used here in integration. That's why here I try to write the formula to be used. If acceleration is given, actually we have two formulae are there for acceleration to find out the velocity now. One is dv by dt, other is v dv by ds. ds means dx, displacement. Okay, and you have to understand that when to use the first one and when to use the second one. Simple, Nana. Acceleration is given as a function of x or t. Once you check here in the question, is it x or time t? It is x. Since acceleration is given as a function of x, I think we should not use this equation. Why? Because it is a function of time. So here, even if you take the cross multiplication, a dt is equals to dv, later to integrate on both sides. Slowly I am explaining, Nana, try to understand. Okay. After integrating on both sides, to integrate, acceleration should be given as a function of time. As a function of time means, say, if a is given as 2t plus 3t square, then you can use this equation. But it is not given as 2t plus 3t square. It is given as 2x plus 3x square as a function of x. That's why here I am going with the second equation, Mama. Why? Because it is not helpful for me. So I am going with second equation means by taking cross multiplication again here, a dx is equals to v dv. Next step, I think we know we have to integrate on both sides. Now I'm checking. Yes, acceleration to integrate, it should be given as a function of x. Yes, given as x. So I have to use the second equation. Okay. Is it clear, Nana, now from these two? Or do you have any doubt regarding this explanation? Any doubt in my explanation? No doubt. Very good. Very good. Then come to here, Nana. So I'm going to use the second one. Right. Come to here in the solution. Yeah, good. Integral a dx is equals to, I am going to use integral v dv. Okay. Before integrating, here you have to substitute the limits now. Okay. Substitute the limits means on both sides. Velocity limits, acceleration limits. Okay. Velocity limits here. What are the velocity limits are? Okay. See here. This is it is started from rest, means initially its velocity is equals to 0. So initial thing is the lower limit. Lower in velocity I put here as 0. Okay. After certain x, what is the velocity? I don't know. I don't know means here that velocity, let it be v. I have to find out. Okay. Is it clear? The right hand side, substituting the limit means taking the limits lower and upper. Or do you have any doubt on the right hand side part? No doubt. Okay, good. Come to the left hand side. Right. Okay now. Left hand side here, acceleration, I am trying to take the values. Here, integral. Acceleration given as 2x plus 3x square into dx, okay, is equals to, better I integrate this one. I think you remember that formula, very famous formula, integral x power n dx is x power n plus 1 by n plus 1. Okay, this was the formula in, I think, previous two classes we used the same formula. Okay, I think you remember. So here I am believing you all. Yes, 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 you remember. Using that formula, here I am writing, instead of x, v is given. In place of n, 1 is there, v power. So x power n means x power n plus 1. Here v power n plus 1, 1 is there. So 1 plus 1 by n plus 1, 1 plus 1. So here I am getting v square by 2 and the limits are 0 and v. Okay, here I am substituting the limits by putting the bracket. Lower is 0, upper is v. Okay, till here any doubt, Nana? No. So shall I continue? Yes, yes. Okay, good. So in continuation, first I am going with the upper limit. Nana. Always you have to substitute upper limit first. Okay. First upper limit means I write substitute here. First in place of v is there. So directly substitute in place of v as v only. V square by 2. Complete substitution is over in the equation. Minus, later you have to substitute the lower limit. Lower limit is 0, Nana. So 0 square by 2. Okay, this is the way how to substitute the limits. Okay, then you will get here on the right hand side that is equals to v square by 2. It is appeared to be very easy. Okay, come back to right hand side. Right hand side here, this one in the form of a plus b into dx. Nana, x limits I did not give. Nana, how you got 0 or minus 1? Lakshmi Gayatri, I did not follow what you said here. V equals to 0 or v equals to. Oh, right, right. Okay, no problem. So here 2x plus 3x square into dx, Nana. It is in the form of a plus b. Means we have to use the separation rule. Separation rule means we have to separate the two terms. That is in the next step, integral. Separately write 2x into dx plus, again separately you write integral 3x square into dx. Okay, and then here in multiplication, if there is a constant, that can be taken out. We know it many times we did previously. So that 2 is taken out. Next step, integral x dx plus here 3 is taken out. 3 integral x square dx. Till here, do you have any doubt, Nana? Shall I continue? Shall I continue here? No doubt. Okay, okay, okay. In continuation, we are going to that. Okay. Here, again, look at this is exactly in the form of x only. We know that formula here. Okay. That formula is x power n plus 1. So, 2 into integral x dx is x power n plus 1. That is 1 plus 1 divided by 1 plus 1. Okay, plus this integration is over, plus, okay, better I write it little away here, is equals to e square by 2, plus this is 3 into, again it is also in the form of x power n dx. It is the starting order. Okay, so x square means the integration is x power n plus 1, that is 2 plus 1 divided by 2 plus 1, n plus 1 by n plus 1. Okay, so here you are getting this is x square by 2. So 2 cancel, you will get x square after cancelling 1 plus 1, 2, 2. Yeah. You will get such type of equation. Exactly. X square plus here 2 plus 1, 3 cancel. Okay. Then you will get x cube is equals to v square by 2. But keep in mind, we did not substitute the limits here now. Okay, those limits I have to give here. Okay, find the velocity of moving particle with an acceleration is equals to how much? Find the value at x is equals to, oh, better I write there only, Nana. You may get some confusion here. Okay, here only I write. Find the velocity of a particle moved with an acceleration this much. When at, here I write, at x is equals to say some 2 meters. Okay, it is started from rest. Better I write here to avoid the confusion. At x is equals to 0 meters. Now is it clear, Nana? Now out of these two, who is the upper limit and who other is the lower limit? Out of 0 and 2, x limits. Oh, Amok got the answer. Okay, good, good, good. Yeah, yeah, yeah. You are right. Amok said correct, Nana. Yeah, Lakshmi Gayatri also correct. Still, any others? Oh my goodness. Only two students got the answer. Um, yeah, right, right, correct. Tanisha correct. Srestha correct. Shivani, I think. Okay, okay. Shivani wrong, I think. And okay, maybe Akhil also wrong. Ishan, boy, no, I think you are also wrong. You got the wrong answer. Okay. It is simple one, Nana. Why few people got here wrong answers? I don't know. Check here. Lower limit, I think all of you took 0. Am I right? Why? Because it started from rest at x is equals to 0 initially. And upper limit he is asking at x is equals to 2. Upper limit is 2. Did you say? Now it is correct, Mr. Akhil. Yes, yes. Okay, I think now you will get the answer. So first upper limit, if you substitute here, that is 2 square plus here 2 cube. This is complete substitution of upper limit. Minus lower limit is 0. 0 square is 0 plus 0 cube is also 0. Is equals, now it is correct, Shiva. V square by 2. Okay. Don't put any question mark. Now it is correct. Okay. 2 square is 4. 2 cube is 8. 8 plus 4, 12. Right. This is 12 is equals to v square by 2. That implies v square is equals to 24 by taking cross multiplication, and v is equals to root 24. Root 24 means 4 6 are 24. So this is 2 root 6. Root 24 is correct. 2 root 6 is also correct. Okay, good, good, good. Now understood, Nana, here how to substitute the limits? What to take at the lower and what to take at the top. Understood. Okay, good. Yes, yes, yes. For my, uh, yeah, 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 yeah. Right, correct, correct. Uh, where you got the trouble here, Mr. Ishan boy? Means I have to come to know now where you are facing the trouble here. integration that you have to practice. Man. I gave the formula here. Using that formula every time we have to integrate. Okay? Differentiation you solve in the same way integration we have to do. Okay. If you face any problem in substituting the limits, then I will give one more example. What to do now? Will I give one more example, Mr. Boy? Yes, yes. Okay. Right. Here we take example Ishan here. Yes, yes. Go with one more example. What is that? You practice. If you practice more, you will get more ideas here. Okay. This time, better I go with acceleration A is equals to given as uh, 2x cube plus, better I take minus 2, that's it, minus 2, 2x cube minus 2 acceleration. Okay, Nana? Already we solved based on x, so I take here t, 2t minus 2. That's better, so that we can practice on the other part. 2t minus 2. Find the velocity um, at t is equals to take some 2 seconds. Okay. Uh, Initially take t is equals to 0, Nana. At t is equals to 0, consider its velocity as 1 meter per second. Okay. Now, keenly observe, Nana, what I am doing, Mr. Ishan. Here, first, okay, you should be thorough with the formula. What is this? I went to which page? Oh my god. I went to sixth page. Okay, no problem. How to remove the pages and the middle pages? Is there any option to remove the middle pages? Do you have any idea? No idea. Okay, right. Uh, okay, right. Okay, that's better. Right. Come to here, page number 6. Yeah, got answer. Yeah, good, good, good. We will check it, Nana. Mr. Ishan, already if you got the answers there, okay, we also do quickly. Mr. Ishan, try to understand this is given as a function of time, Nana. Function of time means here, look at the formula. Function of time means I have to use this formula, Nana. Okay, by taking the cross multiplication from differentiation. So dv is equals to integral dv is equal to integral a dt. So I'm going to use that formula here. Okay. So integral dv is equals to integral a dt. Yes. Uh, what is this? Amok got different answer. Lakshmi Gayatri got another answer. Okay, I will check here. Right here, Mr. Ishan, integral a is I'm going to substitute 2tq minus 2 into dt. Okay. And on the other side, look at Nana, there is no term here. If there is no term, you can cancel these two and directly you can write it as v. Understood this step, Nana? Say simple yes or no. Yes, that's it. Over. Okay. After getting the value, Nana, here we have to substitute the limits. That's what I am saying from the beginning. Okay. See here, in that time, it is started at t is equals to 0. Starting limits are lower limits, 0. At that time, look at the question. Given the velocity as 1 meter per second. So at the velocity, put the lower limit as 1. Did you understand this one step? Simple. Yes or no? Yes, very good. Come to the upper limit. Upper limit means final values. Finally, at what time he is asking? At t is equals to 2 seconds. So finally, I take here the limit as 2. Oh my goodness. The four students got four different answers. Wow. Okay, okay. Then here, oh, fifth answer. Okay. At t is equal to 2 seconds, Nana, Mr. Ishan boy, the velocity I don't know. That's why I take it as v. So is it clear, Nana? This step particularly, both sides, left hand side and right hand side. Understood? Yes, good. Then here substitute after integration. Good, Nana. After integrating, substitute the limits. What to do, sir? First upper limit. Left hand side already you integrated. So here, sir, sixth answer, right? First is upper limit, Nana. Substitute here in place of v. Oh, Lakshmi got the wrong answer. Okay, check it. V upper limit minus in place of v substitute the lower limit. In place of v, I am substituting 1. Okay. This is the way how to substitute the limits. Right? No two answers are matching. Different answers you are typing there. Simply. Okay, we will come to here, Mr. Ishan boy. Then here, this is under subtraction. You know this even in differentiation also. Just a separation rule. So I'm separating the two terms here. So integral first 2t cube into dt minus integral 2 into d. Did you face any trouble here, Nana, in this step particularly? Oh, right. Ishan boy? Uh, okay, okay, okay. Satvika, okay. Ishan boy? Ishan boy mutated to Ishan girl? No, I think. Where are you, Mr. Ishan boy? Ishan left IU. Why? Arre, arre, arre. Okay. Hmm. You know, all of you students able to understand this one? Yes, yes. Okay, good, good, good. Now come to here. I think he joined in YouTube, Mr. Ishan. No, not. Okay, no problem. Ah, then here what to do? We have to take two constant out into integral t cube dt minus again here constant is there in multiplication. 2 can be taken out integral dt. Okay. And here while integrating here t cube means x power n dx model x power t power n plus 1 that is 3 plus 1 divided by n plus 1, 3 plus 1, minus 2 into integral dt. I think you can say nothing is there in between the two. Nothing is there means you can cancel and directly you can write it as t. So, do you face any trouble here, Nana? Anyone can express frankly. Oh, now Ishan came back. Mr. Ishan. Ah, right, right, right. Good. Now we have to substitute, Nana, here the limits. Okay, okay, no problem, no problem. Now, once you check these steps, Nana, able to understand or not? Amog answer wrong. Array, what Amog, Mr. Amog? Once you put the answer, I have lot of confidence on your answer. Ah, right, good. Next time, don't put the wrong answers. Okay, okay, right. Right. Next, Nana, look at the time limits. Here I am substituting those are 0 and 2. So 0 and 2. Here also 0 and 2. Ah, good, good, good. 5. Okay, okay, okay. All right, we will check now. We are almost coming to this. I think it is 5. Maybe. All right. V minus 1 is equals to, I'm getting here fast. This is 2 t power 4 by 4 in the limits. This is 0 to 2 minus that is 2 in the limits 0 to 2. Okay. Better I cancel here. 2 2's are cancellation. Now I am going to substitute. I think maybe correct. This is correct. Okay. T power 4 means first upper limit, Nana. 2 power 4 by 2. Okay. Minus lower limit 0 power 4 by 2. Upper and lower limits substituted here. Okay. Minus 2 into, here also first upper limit 2 in place of t, minus lower limit in place of t, that is 0. So in substituting the limits, do you have any doubt, Nana? Once you see there, if you have any doubt, you can express so that here only we will get more clarity. Able to follow how to substitute the limits? Yeah, yeah, okay, good, good. Then this will be 2 power 4 means 16, Nana. 16 by 2 is 2 eights are. This is 8. Of course, that is 0. It is 5 only. This time is it is correct. Minus 2 twos are 2 minus 0 is 2, Nana. 2 twos are 4. Okay. So 8 minus 4 is 4. So V minus 1 is equals to 4. Therefore, V is equals to 4 plus 1 taken to the other hand. 4 plus 1, that is 5 meters per second. Finally, all of you got the correct answers. Initially, with some mistake in the middle, I think. So still not getting the proper way. So better I go with one more example. No problem. Until we get some confidence on these type of questions. Okay. Can I give one more, Nana? Shall I give one more? Yes, yes, yes. Okay. Now this one, try to get the say correct answer, Nana. Okay. Right. Come to here. Next example. This time I am giving the velocity of a particle is V is equals to, okay, this time I'm giving very simple one. V equals to 6, better I take 60 by t square. Okay. Nothing to worry, Nana. Just take it to the numerator, then you know the formula to substitute. what to substitute. Okay, meters per second, right? Find the velocity at t is equals to, say, some 2 seconds. Consider its velocity at t is equals to 1 second as, say, some 40 meters per second. Okay, so will we start the question, Anna, here? Come to the solution. Sorry, consider, find the not velocity, Anna. Velocity is given. Find, sorry, it's my mistake. Find the displacement. Find the displacement, not velocity. First, which formula you are using? You say here, and I will write. Velocity and displacement are related as V is equals to, I think, ds by dt, if I'm not wrong. Okay. And then here velocity and displacement relation after getting, again we have to cross multiply. Yeah, right. Again cross multiplication. V dt, okay, V dt, yes, and then integration. V dt is equals to ds, and then integrate on both sides. That's it. Yeah, good. So shall I go with that equation, Anna? Able to follow this formula? Right? Then come back to here. So I'm going to use the formula. Yes. That only I'm going to use. Integral ds is equals to integral vdt. Okay. Whatever we learned in differentiation, that only we are using in integration. That's it. Nothing is there. It's simple actually. Okay, if you we follow properly. Yeah, good. Good boy. Right. And now see here, Nana. This is equals to integral v is given as 60 by t square into dt. Okay, is equals to, on the other side, very simple. There is nothing in between these two, so directly we write it as yes. But we have to put the limits there and here. Oh, good. Right. We will check next answer. I'm seeing here the displacement. I don't know. Oh, sorry. No, it's not velocity. Uh, it's a displacement. At t is equal to 1 second as 40 meters. Okay. Lakshmi Gayatri. I did not change any numerical value now. Lakshmi Gayatri. Okay. Here, Nana, yeah, t is equals to 1 second means lower limit 1 second. At that time, the displacement is 40 m. Is it invalid, Nana? Oh, zero is not there now. Why it is invalid? We'll check it. S is 40 at t is equals to 1 second. Sresta once check, Nana. And at t is equals to 2, what is the displacement he is asking? That I don't know. So I take it as yes or. Okay. Amok, how much you got, Ra? Others this time not responding, doing still doing. Okay, right. Others, okay, okay, no problem. I also check here integral ds, that is yes, and at t is equals to 1 second lower limit. The displacement is given as 40. So at displacement I substitute. Ah, yeah, right, right. You won't get any log nana here. This is not t power minus 1. That is t power minus 2. I think there you did the mistake. Sreshta. Ah, okay, right. Yes. Okay. Then here, first upper limit, Nana. Oh, oh, your answer is 20. Okay. And here in first upper limit, this is yes, minus the lower limit is 40. Straight away substituting here is equals to, now I am going to take the integration on the right hand side. 60 constant in the division. Okay, constant in multiplication or division, it can be taken out. So here 60 integral 1 to 2 1 by t square. T square is taken to the numerator, that becomes t power minus 2 into dt. Okay, okay, okay. But yeah, perfectly at the time of the good concept, you missed the classes, Mr. Manikanta. Okay, one or two times you once see the classes from YouTube and try to cook up as early as possible. Now, this is important concept actually. Okay, don't delay and don't take rest. Okay, if you did not understand, one more time you watch and try to understand the concept. Okay, why? Because this integration and differentiation we never leave until we complete our engineering. Okay, not intermediate. Even after in engineering also many times we use. So this is important thing. Right, come back to here, Nana. This is s minus 40 on the left hand side is equals to here 60 into, this is not minus 1. So we can use our formula integral x power n dx formula. That is x power n plus 1 by n plus 1. Okay, in the recorded video already I said this is not valid only when n is equals to minus 1. Okay, so it is not minus 1, so you can directly take it t power minus 2 using this formula. X power means t power n plus 1 minus 2 plus 1 divided by n plus 1 minus 2 plus 1. Okay, so this is equals to 60 by minus 2 plus 1 is minus 1 into t power minus 1. This is minus 60 into t power minus 1 is 1 by t. Now I am substituting lower and upper limits. That is 1 and 2. Okay. Now look at here, minus 60 into I am getting, this is first upper limit. Now in place of t, 1 by, in place of t I am substituting 2 upper limit minus 1 by t lower limit is 1 in place of t. So I'm getting here minus 60 into half minus 1. Half minus 1, you know, this is minus half after taking LCM. So minus 60 into minus half I got. So I'm getting here 230 is, I think both the answers wrong. Imra, Akhil and Lakshmi Gayatri. Array. Okay, okay. Yes, 100, Isha. Yes, yes. Now it is correct. So this is equals to plus 30. 30 is equals to s minus 40. That implies s is equals to, yes. What is your doubt, Nana? Need more practice. That's it. That's it. It's correct, Lakshmi Gayatri. Okay. If you practice more, it will be very easy. Right? Good. Good. So, in this problem, do you have any doubt, Nana? Again, what Shodasi? Shodasi, you asked. You tried. I think tried to ask something. Do you have any doubt? No or yes? Not responding. Yeah. Correct only. At last fourth step. One, two, three, four. Here or above step. Here or there, Nana. In the above one or below one. Out of these two. Above step. Here just I substitute the limits, Nana. In place of t, I substituted first 2. Means 1 by, in place of t, I substituted 2. So 1 by 2. First upper limit is over. Minus lower limit. 1 by, in place of again t, 1 by t, I substituted 1. Is this one only you are asking, or is still above more, one more above step? You asked for the same? Shorasi? Where is square, Nana? I think it is not a square, Nana. Yo, these are limits, Nana. It is not like 1 by t square. They are limits, lower limit and upper limit. That is not square. Yo, Sri Vidya, what is this? Understood? Okay, right. Good. Right. Now come to here, Nana. Okay, you try to practice. Do you have any as a material, college material, Nana, along with you? No college material. Okay. Only IP at material you have. Okay. Work. Then better Sunday we have, I think, holiday. So by that time I will give one assignment, Nana. Try to practice more on this integration and differentiation, so that you will get some confidence. Okay, na? Right, good. Right. Then here, coming to here, Nana, this part actually there even in IP also there is one question deriving all the formulae like V is equals to U plus AT, S is equals to UT plus half AT square, and V square minus U square is equals to 2AS. Okay, these are all valid for uniform acceleration or non-uniform acceleration. Uniform or non-uniform? Only for uniform acceleration, or valid when the acceleration is uniform. Okay. Now the question is, when the acceleration is uniform, now I'm asking, okay, derive the above equations using the integration method. But keep in mind, acceleration is uniform means acceleration is constant. Okay. For that, I am going like this. First, I want to derive v is equals to u plus at. Okay, I am taking here. Acceleration is constant, that is a function of time. So better I take what I used in the previous problem. Uh, yes, okay. What I used in the previous problem, in this example, Nana, integral dv is equals to integral a dt I use. Okay, means using the formula a is equals to dv by dt as a function of time. That's why I'm taking time function equation and taking the cross multiplication as usual. A dt is equals to dv, and then next step, all of integrating on both sides. Okay. While integrating here, we have to substitute the limits. Okay. To get this type of equation, initial velocity should not be zero. That's why in place of velocity, initial I am taking it as u, final I am taking it as v. Okay. Initially at t is equals to 0, the initial velocity is u. At t is equals to, I don't know, t, the velocity is v. Okay. Now understood the limits here, Nana, on both sides, time limits and velocity limits? Or do you have any confusion here? Yes, yes, yes. Good. So here I am going to take first right hand side integration. Nothing is there. Yeah, good now. Nothing is there. So directly by cancelling the two terms, I write here v, and the limits are u and v. Okay. Now come back to the left hand side. Look at here uniform acceleration. Acceleration is a constant. If it is constant, any constant in multiplication can be taken out. So that constant term a, I am taking it out. Integral dt I write. So understood this step, Nana? Okay. How I took this a out. Why I took this a out? Because a is constant. Constant in multiplication can be taken out. Yes, yes, yes. Good. And here limits are t, lower limit is 0, upper limit is t. Okay, again nothing is there in between these two, so again cancel. I will get here t in the limits 0 to t, and here I substitute first upper limit in place of v. Upper limit is v followed by minus lower limit in place of v. I have to substitute lower limit is u. So in place of v, I am substituting u. Okay. So I'm getting v minus u is equals to how much? Left hand side I'm checking. So a into left hand side upper limit t in place of t minus in place of t 0 0 I substituted. I got v minus u. Now look at here, now I am getting left hand side at, that is equals to v minus u over. Therefore, last step, v is equals to taking u to the left hand side, u plus at. Is it clear? Or faced any trouble in the middle? In the derivation, Anna, getting v is equals to u plus at. This is IP question. What to do, sir, in the third step? Third means 1, 2, 3. Here, Nana, Manikanta, here what I did now, I just substituted the limits here in the above step as well as lower step. Why there is not D? Ayyo, you missed the classes now previously. Arre. Integral dx formula is x, Nana. In the same way, integral dv, the formula is v. Integral dt, the formula is t. Now you understood? Okay, okay. That I explained in the first day only. Okay, right, right, right. Uh, Here, Rachuri Alter, what happened here? Uh, First equation over now. Okay, coming to the second equation. Okay, second part. Come to here. Second equation, look at what he wants. Yes, in terms of t. Okay, yes, in terms of t means I think exactly like in the previous problem only. Yes, in terms of t. So shall I use v is equals to ds by dt? Okay, so I am using here v is equals to ds by dt. Okay, I am starting now. Now take the cross multiplication. V dt is equals to ds. Okay, and next step, all of you know, integrate on both sides. V in the question not given, but here in the first problem we found that I am going to substitute here in place of v. So integral v is u plus at. I substituted into dt is equals to integral here. You know there is nothing there means integral dx is x. In the same way, integral ds is yes. Okay, limits starting from 0 to some displacement, yes. Here also starting from 0 to certain time t. Okay, any doubt here, Nana, in this step? Can I continue further? Shall I go to next step? Yeah, good. Now the separation rule. Addition, separation. So u into dt, that is integral 0 to t, u into dt, plus here integral at into dt. Separation rule. 0 to t. Okay, and this is equals to, better here only you substitute the limits in place of first. Yes, yes only upper limit, minus in place of yes, 0 is the lower limit, yes minus 0. So right hand part is job is over. So we have to check only left hand side. Okay, so here u constant initial velocity, so taken out in multiplication, u integral dt 0 to t, and here in the question acceleration is uniform constant in multiplication, so can be taken out. So a integral again, this is, oh sorry, I forgot one term here, at dt. Oh sorry, this is a t into t, right? So here I am going to write what integral t dt. A is taken out in the limits 0 to t. Able to follow now what I am writing? Yes, yes, okay, right. Then here again this is like integral dx x, so it is ut in the limits 0 to t. But here in between integral dt there is t, one term is there. So x for n dx model we have to use. Yeah, now I think there is some technical issue, Nana. Now she stopped the video. Okay. Now I think you can see the board. Now see here, Nana. This is x power n model means a into x power n plus 1 by n plus 1. That is t power 1 plus 1 by 1 plus 1. There is t power 1, Nana. Okay, in the limits 0 to t, that is equals to yes. Next step very easy, Nana. Lower limit is 0, so no need to substitute, directly you can write upper limit u into t. Okay, Nana, no problem. Okay, all right. Why? Because some students may not see the board if suppose someone opens the video. So u into t plus here, look at, Nana, a into upper limit t square, lower limit I am not substituting, Nana. Why? Because it is 0. I think you understood. By 2 is equals to s over, this is the equation that implies s is equals to ut plus by 2 means half a t square. Same equation we got here. Okay, Nana? Any doubt in this explanation? No. Right. It's already 3:32, Nana. Third equation tomorrow I will explain. Right. Uh, shall I leave now, or do you want any pages? Okay. Right. Coming to here, Nana, first page. This is the first page. Okay. Next, we see many things, many pages here, and this is the second page. This is the third page. This is the fourth page. Okay. Bye now. Bye everyone, Nana. Bye.